Hello. Okay, so we're doing now still a partial fraction decomposition method and integration of a rational function. So now we're going to deal with case 4. Case 4 basically is where the denominator q of x is a product of distinct, irreducible quadratic factors, where some of them are repeated. Okay, the quadratic factors will look like this. You have q of x. So q of x is basically an example is quantity x squared plus a squared all squared times quantity x squared plus b squared all squared. So you can see x squared plus a squared is repeated 2 times. So the partial fraction decomposition for this case is that you're going to write, so you take x squared plus a squared, and then on the numerator you put ax plus b plus, and then you go to the second term, which is quantity x squared plus a squared, now all squared, and then you continue with the alphabet cx plus d as a numerator, and then you do the same thing with the second repeated irreducible quadratic factor. So you end up with this partial fraction decomposition. Okay, so that's type 1, but we will discuss only type 1. So let's do an example. So if we look at the first example here, they want us to integrate x to the fourth plus 1 over x times quantity x squared plus 1 all squared. So we know this is a x basically here factor, basically tells us this case 1, and then a quantity x squared plus 1 all squared, that tells us we're dealing with case 4 because x squared plus 1 is repeated 2 times. So we start with case 1 when you did the partial fraction decomposition, so it's going to be a over x, and then a plus, and then we start with x squared plus 1, and then a numerator we put bx plus c, and then we continue with the next denominator is quantity x squared plus 1 all squared, and the numerator we continue with the alphabet dx plus e. So and then we have to integrate each term. So to integrate, so the first integral, we know a is a constant, so we can move a outside and then only integrate 1 over x, which is just natural log of absolute value of x. For this term, we'll have to break this down into 2 terms, or 2 integrals. The first one is going to be bx over x squared plus 1, and then plus the second integral is going to be the integral over c over x squared plus 1, this one here. So this one integral is now 2 integrals. So we know here, we know b is a constant, we can bring it outside, and then we can integrate x over x squared plus 1, which we know by the u substitution is going to give us 1 over 2 times ln of absolute value of x squared plus a. You already did this case. And then here we have the integral over c over x squared plus 1. C is a constant. When we move c outside, then we integrate 1 over x squared plus 1, which is just the arctangent of x. So now we go to the next integral. So d is a constant. So here we will integrate x over x squared plus 1 all squared. Okay. Which again is a u substitution because we have x in the numerator. So u is going to be x squared plus 1. So this integral will give us, so what you're going to end up integrating is 1 over u squared, which basically means you move u on the u squared on the numerator becomes u to negative 2, and then use the power rule of integration, and then bring u back. You get 1 over 2 times negative 1 over x squared plus 1. Now the last integral that we have not done that yet, so I'll do this integral. So I pull e outside, and then try to integrate 1 over quantity x squared plus 1 squared. So the explanation is given here. Okay, so here This brings us to case 2 of the trigonometric substitution. So x equals tangent theta, and then a dx is secant squared theta d theta. X squared plus 1 is then tangent squared plus 1, which is secant squared theta. So we go and plug in all the data. So dx is a secant squared theta d theta, which is this. And then the bottom, x squared plus 1 is secant squared. And when you square it, you get secant square, which is secant to the 4th. But then we can simplify 1 secant square. We end up with 1 over secant squared theta. But 1 over secant theta is cosine theta. So this is just a cosine squared theta that we're going to integrate. To integrate cosine squared theta, we know we have to go and use the double angle formula for cosine squared theta, which is 1 over 2 times quantity 1 plus cosine squared theta. And then bring a half outside, and then integrate 1, you get theta. And when you integrate cosine 2 theta, you get sine 2 derivative. And but then we use this double angle formula for sine 2 theta, which is a 2 cosine theta sine theta. Plug this in, simplify 2, we end up with 1/2 times quantity theta plus cosine theta sine theta. And we then go draw the right triangle. So remember that trigonometric substitution was x equals tangent theta. If you go back here, the trig substitution, so the trigonometric substitution is x equals tangent theta. So we're going to use that to draw the right triangle. So x equals tangent theta. So tangent theta is opposite over adjacent. So x over 1. And then by Pythagorean theorem, we know the hypotenuse is going to be x squared plus 1 squared, put them under the square root. So then we know, since we're using x equals tangent theta, then theta is going to be arctangent. So this theta is going to be arctangent of x. From the right triangle, we are going to read cosine theta. Cosine theta is usually adjacent over hypotenuse. So it's going to be 1 over square root of x squared plus 1. Sine theta is going to be opposite over hypotenuse. So it's going to be x over square root of x squared plus 1. So we take those data, we put them into the solution, and then we get our final answer in terms of integration. Okay. So now we still have to find the undetermined coefficients a, b, c, d, and e. Okay. Because after we did the partial fraction decomposition, it was given like this. So there was the partial fraction decomposition of the problem. So we needed to find a, b, c, d, e. So again, as we said, for all cases, to clear all fractions, you'll have to multiply the equation by q of x, which is x times quantity x squared plus 1 all squared. So you multiply this, you're going to clear everything. So on the right side here, you will be left with x to the 4th plus 1. On the left side, in this case, you will simplify x. Okay, and then you're going to have a times x squared plus 1 all squared plus quantity bx plus c times, we simplify x squared plus 1, we're going to have 1 x squared plus 1 left, and then x. So we're going to multiply by quantity x squared plus 1 and plus times x. Here we're going to simplify quantity x squared plus 1 all squared. We will have only x left. So this quantity dx plus e will only multiply x. So we have this equation. So now we can, wherever we see, we can FOIL everything, expand everything, and then end up with this polynomials. So here we're going to FOIL this out and then distribute a. Here we're going to FOIL this and then multiply by x, and then it give us this. And then over here we're going to distribute x, and then we get dx squared plus ex, and then equals to x to the 4th plus 1. So this is a case now of comparing terms. Since the highest power of x is 4, so we're going to compare the x to the fourth terms. So on this side we have a x to the fourth, and then plus b x to the fourth. On the other side, x to the fourth, the number is in front of it, the coefficient is 1. So we're going to end up with the first equation, a plus b equals 1. And then we go to x to the third. On this side we have a c x to the third, just one term, x to the third. On the other side there is no x to the third, so we're going to set c equals 0. So we get the values of c. And then we go to x squared. We have, this is x squared term, and that is x squared term, and this is x squared term. So we're going to have a 2a plus b plus d. Since there's no x squared term on the other side, we set that equals 0. And then we go to x. We have cx, and then plus ex. So we can write this as a c plus e equals 0. Okay, and then the constant. Here we have a is a constant, and there we have 1 is a constant. So that makes a to be equals 1. So get a equals 1, and then we get a c equals 0. Because we get a equals 1, then a b is 0. You can use the first equation to solve for b. Okay, so b is 0. Now we got a 1, b 0, c 0. From this equation, e plus c equals 0. Since c is 0, that makes also e to be 0. Now we pretty much got everything but d. So d is here. So we know that b is 0. Okay, and then we know also a is 1. So that makes d to be negative 2. So we got all the coefficients. Okay. So then we go to the partial fraction decomposition. We plug in those numbers. Okay. So you can see b is 0, so this term would go away. It's going to be 0. C is 0, so this is going to be 0. And e is 0, so this integral is going to go to 0. So when you plug in, and then d is negative 2. So negative 2 will go here. And the a is 1, so a is 1 is going to go there. So we pretty much has only 2 terms left. Okay, and then we so we get the answer. So that's case 4. Thank you.